Today's video is about the properties of real numbers. This is going to cover page 2 of the guided notes that we used in activity number 1. I would suggest that you listen to the video, watch the video at least through filling out the notes at the top of the page. You have to listen to that much in order to get those notes. And then once you get to number 13 on the page, you can try to answer all of those questions on your own and then come back and check your answers here. I'm going to go over the odd numbers in the video, just like in the last time. And that way you can try the odd numbers on your own, come back, check your answers, get confident in the things that you have right, and correct yourself on things that you didn't understand the first time. And then you can go back and finish the even numbers on your own and feel a lot more comfortable with that content. So let's go ahead and get started. Here is the learning target for today's video. And again, here is today's worksheet. If you have the ability to print it out, of course, you know that I'd prefer that, but I prefer it because it's better for you. But obviously, not everyone has access to a printer, and that's perfectly fine. Notebook paper is great. But this is the part up here that you have to listen to the video to get the notes for. And then all of these practice problems you can attempt on your own and check the odd numbers back here in the video. Okay, on your paper, you won't see this divided line down the middle of each section. I would like for you to draw that in for yourself because I'm going to give you an example with variables and then an example with real numbers. So let's just go ahead and dig right in. So the commutative property of addition states that A plus B equals B plus A. For multiplication, it says that A times B equals B times A. So you can see that these are very similar. The way that I remember this, I'm really big on wordplay and kind of tricking my mind into remembering these things. And so when I think of commutative, I think of communication. And to help me remember this, I think about conversations with my grandma on the phone. My grandma will get frustrated that I don't call her often enough. And I like to tell her that communication works both ways. So the commutative property works both ways. It can be A followed by B or B followed by A. Okay, so when you think commutative, think it works both ways. That's how I remember that, the name of that property. Okay, so like I said, I want to also give you a numbers example. So let's take 3 plus 5. For example, this equals the same thing as 5 plus 3. We all agree that 8 equals 8. So we can see visually how this works. We're going to do the same thing with the multiplication one. 3 times 5 equals 5 times 3. 3 times 5 is 15 and 5 times 3 is also 15. Okay? So let's look at associative. In associative, it says that A plus B plus C equals A plus B plus C. I'm going to try that again and try to stay in the lines. Okay. A plus B plus C equals A plus B plus, C. There we go. And then for multiplication, it means that A times B times C equals A times B times C. So for this one, to help me remember, I think about associative. And on this side, A and B are being associated. And on this side, B and C are being associated. So in this case, it does not matter who you associate with, you're going to get the same answer. Okay, so let's look at a number example for the addition. Let's do 3 plus 5 plus 7 equals 3 plus 5 plus 7. Now remember, we have to complete what's in parentheses first. So on the left side, 3 plus 5 would be 8. 8 plus 7 would be 16. On the right side, no, 8 plus 7 is 15. I'm sorry. On the right side, we have 5 plus 7 would equal 12, plus 3 would also equal 15. So we see that these are both equal. This property works. Yay. Okay, so now multiplication. We can say that 3 times 5 times 7 would equal 3 times 5 times 7. So if we think about it on the left side, we do the 3 times 5 first. That equals 15. And 15 times 7 is 105, I think. So then 5 times 7 on the right would be 35 times 3 is also 105. Okay, so let's move on to our next property, the identity property. So the identity property is what you can do to a number to get that same number back. So for addition, if we have a number A and we want to add something to it, because this is an addition property, but we still want it to equal A because that's its identity, we can add 0 to it. So for our example, let's do 3 plus 0 equals what? 3. Hooray! And then for multiplication, if we want to multiply A by something that gives us back A because that is its identity, we can multiply it by 1. So if we have 3 times 1, that equals 3. Next, we have the inverse property of addition. So the inverse property for addition is what you can do, what you can add to a number to make it equal 0. But the inverse property of multiplication is what you can multiply a number by to get 1. Okay, so these are different. In addition, the inverse means it equals 0. In multiplication, the inverse means it equals 1. So that's a little bit tricky. You're going to have to put some effort into remembering that. So what can we add to A to get 0? We can add negative A. So if we had 3 plus negative 3, that would give us 0. Now, A times what gives us 1? A times 1 over A gives us 1. So if we had 3 times 1 over 3, so 3 times 1/3 would give us 1. Now our final property to look at is the distributive property. And the distributive property combines multiplication and addition. So there's not two separate properties, it's all one. And this tells us, so I'm going to put a little line here for our two different examples. This tells us that A times B plus C equals A times B plus A times C. So as if we had distributed the A. You guys are probably pretty familiar with this property. So let's look at 3 times 5 plus 7. This equals 3 times 5 plus 3 times 7. And if we were to look at the left side, we would probably solve that by adding 5 and 7 to get 12, then multiplying by 3 to get 36. On the right side, we would do this first. We would get 15 plus 21, which also equals 36. So we see that those do equal. and that property works. Hooray. I would really hope so, since someone much older and more educated than us figured it out. Okay. Let's name that property. So, let's look at number 13. First of all, we know that this is a multiplication property because it doesn't have any addition in it. So, now we just need to figure out which property of multiplication that it is. Whenever we see stuff in parentheses, my first thought is to consider the associative property. So, in order for it to be the associative property, these have to be in the same order, 528, 528, but the parentheses have been moved. And that's exactly what we have here. So this is the associative property, because remember, it doesn't matter who you associate with, you'll get the same answer. This is the associative property of multiplication. And what you can do, you do have to identify if it's multiplication or addition, but you can do associative and put the M in parentheses for multiplication. Now, we have 7y plus negative 7y equals 0. So where did we have something that you add the negative version and you get 0? If we look back at our chart, this is the inverse property of addition. Okay, number 17. We have x squared plus 8x plus 1, x squared 8x 1, but the parentheses have been moved. This is the associative property as well, but this is addition because these are all plus signs, all addition. Okay. Finally, we have number 19. This is backwards to what we would normally see this, but all this is saying is that 3 times m plus n equals 3m plus 3n. That is the distributive property. And remember, the distributive property involves both addition and multiplication, so it does not have to get a subcategory. All right. The inverse property tells us more than just, we use it for more than just identifying what property is being used. We can actually find the additive inverse and the multiplicative inverse of numbers. So let's recall that the additive inverse is what you can add to a number to get 0. And remember, that always equals negative a. The multiplicative inverse is what you can multiply that number by to get 1, and that will always be 1 over a. So, if we want to find the additive inverse of negative 8, we would use negative 8. Well, 2 negatives make a positive, so the additive inverse is 8. The multiplicative inverse will be 1 over negative 8, which just equals negative 1/8. So the number 23 has 6w. What can we add to 6w to get 0? We can add negative 6w. And then, what can we multiply 6w by to get 1? We can multiply it by 1 over 6w. So again, this is the additive inverse of 6w and the multiplicative inverse of 6w. And finally, we have something called the closure property. So the closure property says a set is closed under an operation. So like down here, it says integers are closed under multiplication if the operation always produces an element of the same set. If an element outside the set is produced, then the operation is not closed. So that sounds a little like a lot, but let's just talk through it. So this says integers are closed under multiplication. So if I take 2 integers, it doesn't matter what they are. Let's say negative 3 and 2, and we multiply those. we're going to get -6. The question is -6 still an integer? And it is. So let's try to think, is there any possible combination of integers we could multiply together and get an answer that is not an integer? And the answer is no. There's no way to multiply two integers together and get anything other than an integer. So that means that integers are closed under multiplication. So this is true. Okay? So let's look at number 27. Number 27 says that whole numbers are closed under division. So this is suggesting that if I take any whole number divided by any other whole number, I will only get a whole number. So let's think of two random whole numbers. Remember, whole numbers start at 0 and then include all positive integers. So if we took 5 and divided it by 7, this does not equal a whole number. This is going to give us a decimal. So 5 sevenths actually equals 0.71428 blah, 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 blah. It's a very long number. It's actually irrational. So I divided two whole numbers and I did not get another whole number. So that means that this is false. Whole numbers are not closed under division. It also says we must give a counter example if the statement is false. So all I have to do is write 5/7. That's the example I used to figure out that this statement was false. And so I just put false 5/7 because 5/7 is not an integer, and that proves that this statement is false. That's the end of today's video. Make sure that you fill in everything on this paper to get full credit. All the odd numbers are here. The even numbers are for you to do on your own. Thank you and have a good day.